Hello viewers, welcome to the YouTube channel of Lightway Research and Technology Center. In this video, I will show you how to perform unit root tests in Eviews. These are the three unit root tests that we are going to look at. The first one is Augmented Dickey-Fuller test, which is commonly referred to as ADF. The second one is Phillips-Perron test, also known as PP. And the third one is Kwiatkowski-Phillips-Schmidt-Shin test, which is popularly known as KPSS. Now let us look at the first one. Let us look at the null hypothesis, the alternate hypothesis, as well as the decision rule. These things are very important. You need to know them so that you will not have issues when you are trying to interpret your results. Now let us take a look at the null hypothesis for the Augmented Dickey-Fuller test. If you look at it closely, you will notice that the null hypothesis is different from the alternate hypothesis statement. For the null hypothesis, the rule says that series is not stationary. That is, series has a unit root. While the alternate hypothesis says that series does not have a unit root. In other words, series is stationary. So the series can also be reversed as variable. Now for the decision rule, this is the guide. Reject the null hypothesis, that is, series is not stationary, and conclude that the series is stationary if the absolute value of ADF test statistics exceeds the critical value at 1%, 5%, or 10%, or if the probability value is below 1%, 5%, or 10%. Otherwise, fails to reject the null hypothesis and concludes that the series is not stationary. Now, what am I trying to say here is that if you run your if you do your analysis in Eviews and when you notice that the ADF test statistics, the absolute value is greater than any of these three critical values, you conclude that the variable is stationary. Please take note, 5% here is the conventional level, and most times journals will recommend that you should stick to 5% instead of 10%. You can use 10% and 5% freely, but most times you see journals that will reject 10% because it's too high. So when you are doing your analysis, I would suggest you should stick towards 5% and 1%. So if you notice that your series is not stationary at 5%, you can make use of any other unit rule test. Now let us go to Phillips-Perron's unit rule test. Now look at it. The null hypothesis is the same. The alternate hypothesis the same as well as was the decision rule. In other words, there is no difference between the conditions for using ADF and PP. The only difference that comes in is in the equation specification. For the PP unit root test, the null hypothesis is series is not stationary, while the alternate hypothesis says that series is stationary. And the decision rule as well, you have to look at the absolute value. So if the absolute value of the PP test statistics exceeds the critical value, that is 1% or 5%, you can conclude that the series is stationary. Take note, you have three critical values. The first one is 1%, second one is 5%, and the third one is 10%. So if the test statistics is greater than any of those three critical values, you conclude that the series is stationary. Or if the probability value is less than 1%, take notes, 1%, 5%, or 10%. Otherwise, you fail to reject the null hypothesis. In other words, you accept the null hypothesis and conclude that the series is not stationary. Now let us check the third one, which is Kwiatkowski-Phillips-Schmidt-Shin test. This one is popularly referred to as KPSS. So you will hear me saying KPSS, KPSS. Now the known hypothesis for KPSS is different from that of PP, also ADF. In fact, the known hypothesis for KPSS is the alternate hypothesis for PP and ADF. So for KPSS, the known hypothesis says that the series is stationary. That is, the series does not have a unit root, while the alternate hypothesis states that the series has a unit root. In other words, the series is not stationary. Now, if you look at the decision rule very well, you will also notice that there's a slight difference. The decision rule is slightly different from that of the ADF. Let me read it out. Reject the known hypothesis and conclude that the series is non-stationary. You know, for ADF and PP, it was stated that you reject the known hypothesis and conclude that the series is stationary. But in this case, it is what? Non-stationary. If the KPSS test statistics exceeds the critical values, either 1%, 5%, or 10%, you just need to pick one or two, preferably 1% and 5%. Otherwise, fails to reject the known hypothesis and conclude that the series is stationary. So what we are saying here is that if the KPSS test statistics exceed or greater than the critical value at 1%, you can do what? You can proceed and do your first difference. Why? Because it shows that the series is what's not stationary. Please take notes. KPSS does not have probability value, unlike ADF and PP. So now let me take you through the steps how to perform the unit root test in Eviews. Here I have my Eviews work file. Please, if you don't know how to arrange data in Excel or how to transfer data from Excel to Eviews, please kindly go through our previous videos. We have done videos on how to arrange time series data, panel data, both quarterly, monthly, and annually in Excel, and how to transfer the data from Excel to Eviews. Before me, I have my time series data. Here I have oil price, and this is what oil price returns. I use this particular work file to explain how to generate volatility series in one of our previous video. If you need that video as well, you can just check through our channel. I'm very sure you will see it. Now, to check your unit root test, you click on oil price twice. You click on it twice. Then you go to view. You click on view. Then come down to unit root test. Please take notes. In this video, I will not explain the inspection of graph, also parallelogram. Those ones are basic, so I believe they are not that important like the key unit root test. So now, under test type, you will see that we have Augmented Dickey-Fuller test. So if you click on it, you have list of other unit root tests. The first one, Augmented Dickey-Fuller test, followed by Dickey-Fuller test, followed by Phillips-Perron, followed by Kwiatkowski-Phillips-Schmidt-Shin test, followed by this and Eviews. So now, if you don't want to use ADF, you just make changes there. Now, let us start with ADF. Now, here you will see that we have tests for unit root in level, first difference and second difference. This second difference is not common, particularly in economics. So we'll start with test for unit root in level, which is also known as I0. Then we have another panel which is include in test equation. if you are used to ADF, PP, as well as KPSS test equation, you will notice that there are equations whereby you will have intercept. You will see another equation where trend is included, and you will see another one where both trend and intercepts are not included. So that's what this panel is trying to address. And here we have lag length, which is the third panel here. We have lag length, under which we have automatic selection. There are some scholars that still believe that they need to do automatic selection before they can even run unit root test. So it is that particular test, maybe AIC or CSIC, that will now inform them of the lag that they will use for the unit root test. But in our case, we are not interested in that part. We are going to stick to the default setting. So you don't need to change anything here. The user specifies, don't change it. Maximum, this is lag length. So the maximum lag length here is what is 17. So Eviews will automatically select the optimal lag for us. So now, if you want to start your unit root test, I would suggest that you should start with none. That is if you want to use the three options under the second panel here. But most times you can you can just stick to trend and intercept, particularly if you have limited time, or if the your article, if you don't have time to write pages or to interpret results of different unit root tests, you can just stick to trend and intercept and make use of other techniques to authenticate your results. But in this video, I will show you how to do that of none, when none of trend and intercept is included in the test equation, when only intercept is included, and when trend and intercepts are included in the test equation. So let's start with none. So here you click none. We want to check the unit root, whether oil price is stationary at level. Once you do this setting, then you click on OK. Here we have our results. Take note that the decision rule for ADF is that you reject the null hypothesis. You can see the null hypothesis here, oil price as a unit root. That is the null hypothesis. So the alternate hypothesis is what? Oil price is stationary. And the decision rule is that you reject the null hypothesis and conclude that the series, in this case oil price, is stationary if what? The absolute value. Why do I say absolute value? It's because of this minus. So you are not going to take this minus into consideration. You have to ignore the minus sign. If the absolute value of ADF test statistics is greater than the critical value. Now let us compare the test statistics absolute value. The absolute value is 0.886201. You will notice that this test statistics is less than the three critical values. First one, 1%, test statistics is less than 0.88 is less than 2.57. For 5%, 0.88 is less than 1.94, and at 10%, 0.88 is less than 1.61. And if you look at the probability too, you will notice that it is not significant even at 1%. So with this, you can conclude that oil price is what? Is not stationary at level. Now let us make use of intercepts. So you leave this one the way it is, then you go to this second panel. Now let us include intercepts in our equation or in our model and see whether there is going to be changes in the results or not. So once you change this to intercepts, then you click on OK. Once you click on it, you have another result. You can see the previous one is 0.33. In this case, is what? 0.12. But the fact still remains that oil price is what? Is not. It has a unit root at level. Why? Because one, the probability value is greater than 10%. Two, the absolute value of ADF test statistics is less than the critical values. You can see the lowest is 2.57, which is greater than 2.46. So we can conclude that oil price is what? Is not stationary at level. Now let us include trend and intercepts in our test equation. So we pick this option 3, trend and intercepts. Take notes, we still stick to what? Level. Let us see the results. Wow. For trend, when trend and intercepts are included in the test equation, you can see that the result change. Instead of insignificant probability value, we now have a significant probability value. This results, you can see that the probability value is less than 5%. This is 0.04, which is less than 0.05. Also, take notes, the absolute value of ADF test statistics is greater than what? The critical value at 5% as well as 10%. So based on these results, we can say that oil price is stationary at level. It was stationary at level. But we must not stop there. Why? Because two of the options in the second panel shows that it is not stationary at level. So let us go back and take this to none, and here instead of level, let us go for first difference and see what is going to happen to the results. You know, in the previous results, there is evidence that oil price is not stationary at level. Now let us check. Wow, you can see that when we check for the first difference, the probability value is significant even at 1%, and the absolute value of ADF test statistics is also greater than the three critical values, because here we have 14.04. For the first critical value is 2.57, 1.94, the second one, the third one, 1.61. So now, the ADF unit root shows that oil price is stationary at first difference. That is a situation whereby trend and intercepts are not included in the model. But let's go and check for this one when only intercepts. You know, in the previous results, the unit root test shows that oil price is not what? Stationary. So let us check at first difference and see what's going to happen. Yes, the result is similar to the first difference of a situation where no intercept, no trend is included. You can see that the probability value is what? Is also significant, and the test statistics, the absolute value is what? Is greater than the three critical values. So now we can conclude based on these results that oil price is what? Is stationary after first difference. We can't go for the what? The third one, which says that is at level. Why? Because the other two indicated that what? It is not level, it is I1. But for me, I will always go for trend and intercept. So when trend and intercept indicate, because this is the most robust of the three test equation, this is the most robust. But if you take note of something here, we are not sure the level at which oil price is stationary. So to authenticate our results, we need to make use of other unit root tests. So let us go for PP unit root test so that we can be sure the level at which oil price is stationary. Now you go to test type, then you click Phillips-Perron, that is PP unit truth test. We want to make use of that. Now for PP unit truth test as well, the non-hypothesis is not different from that of ADF, the alternate is not different, the decision rule also is not different. In fact, the second panel here, which is the test equation, also have three options like that of ADF. So in this case, let us start with none as well. You know, the none for ADF shows that what the result is not stationary. ADF. Let me briefly summarize the results here. We have none, we have intercepts, then we have trend and intercepts. For none, ADF shows that the oil price is what? Oil price is I1. That is first difference. I1. Intercept also is what? Is I1. And for trend and intercept is what? I0. So now let us check for PP. Let us see the level at which oil price will be what? Stationary. Now let's start with none, and the for test equation for test for unit truth at level. This panel as well, these two panels, please leave it the way it is, the default settings. So what you just need to do is to click OK. So once you click OK, you have your results. Now look at this. For Phillips-Perron, none. For Phillips-Perron at none, the exogenous none, you can see none. The result is what? Is not stationary. Why? The probability value is greater than 10%. But if you are to use conventional level, it's greater than 5%. And another point is that the absolute value of the PP test statistics is less than the three critical values. You can see it's less than all this results. So based on this, we can conclude that oil price is not stationary at level. Now let us check for first difference. So what you just need to do is to click on this first difference and get your results. Your non-hypothesis, which I've already stated as a unit truth, you can see here. Now if you look at it at first difference, you will see that the probability value is significant even at 1%, and the absolute value of PP test statistics is also greater than the critical value at 1%, at 5%, and at 10%. So we can conclude that what? Oil price is stationary at first difference. So let us go back here and say first difference. I want to bring it up here so that it can be clear to all. Yes. Now PP, the result indicates that oil price is stationary at first difference, that is I1. Now let us check for intercepts. For intercepts, what you just need to do is to select intercepts here. Once you select intercepts, you have your, and this one you change it to level. You know, we did level before we proceeded to first difference in the previous one. So here you change it back to level. Then you click OK to have your result. For level 2, you can see that the result is not stationary. Why is it not stationary? The probability value is greater than 5%. And secondly, the absolute value of PP test statistics is less than the three critical values. You can say at 1% less than it, at 5% less than it, at 10% is also less than it. Now let us check for the first difference. Let us check for the first difference. What you just need to do is go to view, click unit through test, then here you change it to first difference. Now you click OK, then you have your results. Now for intercept, PP shows that the variable oil price is what? Is stationary at first difference. Why? Because the probability value is significant even at 1%. And secondly, the PP test statistics, the absolute value is greater than the three critical values here. So now let us go back to our notes and indicate that for intercepts, the result shows that oil price is what? I1. Now let us check the third one. You go to view, unit through test, then you select trend and intercepts. Trend and intercept. This one you take it back to level, then click OK. Now for trend and intercept, the result also shows that what? Oil price is not stationary at level. You can see the probability value is greater than the conventional level, which is 5%. Also, the absolute value of PP test statistics is less than the critical values. So this oil price is what? Is not stationary at level. Now let us check for first difference. You go to view, then click on unit through test. What you just need to change is this: from level, select first difference, then you click OK. Now you have your result. You can see this result is similar to the one obtained for intercept as well as none at first difference. So you can see now that the probability value is significant at 1%, and the absolute value of PP test statistics is also greater. This is 13.61 compared to 3.98, 3.42, 3.13. So these results authenticate our previous findings, that is the ADF result, that oil price is what? Is stationary at first difference. So you come down and put first difference I1. You can see the majority is I1. So there's no way you can dispute this particular result. Now let us make use of the third unit through techniques, which is KPSS. To do that, you go back to view, then select unit through test. Here under test type, you change this to Kwiatkowski-Phillips-Schmidt-Shin test, which is KPSS. Then the first panel, you take it back to level. For KPSS, you can see that we have just two test equation. Equation where intercept is included, and the one where trend and intercepts are included in the model. So let's start with intercepts and see how the results will look like. You click OK, then you have your results. Now I want you to pause the video, or you go back and check the decision rule for KPSS. You know that the non-hypothesis for ADF and PP is what? Is that oil price is not stationary or non-stationary. For KPSS, the non-hypothesis, you can see it here, oil price is stationary. So now you have to take notes of that so that you will not take true situation as false and also false situation as true. Now the decision rule for KPSS is slightly different from that of ADF and PP. If you can recall, under the decision rule, I stated that you should reject the non-hypothesis and conclude that the series is non-stationary if the value of KPSS test statistics is greater than the what? The critical values. Now, if you look at the value of KPSS test statistics, you will see that it is greater than what? The critical values at 1%, at 5%, and at 10%. So, based on these results, you can conclude that what? Oil price is non-stationary at level. Now, let us check for first difference. What you just need to do is to change the first, under the first panel, take it back to first difference, then you check the results. Now, look at it again. Is KPSS test statistics value greater or less than the critical values? If you look at it, you will notice that it is less than the 3 critical values. So this suggests that oil price is stationary. We cannot reject the null hypothesis in this situation because the test statistics for KPSS is less than the 3 critical values. You can see 0.029 is less than 0.739. It's less than 0.463. It's also less than 0.347. So we can now go back to our notes and put it down that for none is nothing. So we just put dash there because KPSS has 2 test equation. Then for intercepts, the result for KPSS shows that oil price is I is what? Is I1. Oil price is I1. Please take note. This is I. Oil price is what? Is I1. Now let us go back and check for a situation whereby trend and intercepts are included in the model. So here you take it to trend and intercepts. Then here you take it back to level. You take it back to level. Then you click OK to see your results. If you look at it very well, you will still notice that the test statistics for KPSS is greater than the 3 critical values. So we have to reject the null hypothesis and conclude that oil price is not stationary. Now let us check for first difference. You go to view, click unit through test. Then here you take it to first difference and click OK. If you look at the test statistics for KPSS, you will notice that it is less than the 3 critical values. At 1%, you will see it's less than 2, 0.2 is less than 0.21. It's also less than 0.14. It's also less than 0.11. So based on these results, we can conclude that what oil price is also stationary at first difference. So here you go to trend and intercept, then you pick you type I1. You can, if you inspect the results very well, you will notice that I1, that is first difference, dominates. So there is no way we have used 2 different techniques to authenticate our ADF results. So you can say based on the results of the ADF, PP and KPSS, oil price is what? Is stationary at first difference. But take note, if ADF, the non-intercepts, PP, non-intercept, and so on and so forth, shows that the result is at level, there's no need of checking for it. Shows that oil price is stationary at level. There's no need of you checking for what? For the first difference. You just stop there and check and make use of the other technique of unit through test. So with this with these results, we have come to the end of this video, and I believe I've been able to show you how to make use of 3 different techniques to check for stationary in Eviews. This is oil price. So if you don't know how to present your results in tables, what I would just advise you is that you should make use of your internet. Just go to Google, check for 2-3 articles, look at the way the authors presented the results, then just adopt one of the styles and also present your results. I believe you won't have issue with that. So please, if you are just coming across our channel for the first time, kindly click on the subscribe button below to join Lightway Research and Technology Center YouTube channel. Also, please switch on your notification bell so that you can be informed, or you can be notified when we release new videos on how to perform different tests or different analysis in Eviews, Stata, R, SPSS, HEMOS, and others. And for all our existing viewers, we say a big thank you to you. Please continue to share our video with your friends, your colleagues. Thank you very much.